and welcome back to TensorFlow. So today we are going to solve another Leetcode problem, which is this three-sum problem. This is one of the most important problem in data structures and algorithm, and it is frequently asked in coding interviews at top tech companies like Google and Amazon. So before diving into this problem, I will highly recommend you watching my previous videos on two sum and two sum 2, because three sum is similar to these two problems. I would say it is the upgraded version of two sum and two sum 2. So now let's talk about the problem itself. So even though it is labeled as a medium, but some people find it quite difficult. So I don't know why they categorized it as medium. It should be hard here because this problem is quite difficult. So now let's read the problem and see what the problem statement is. So the problem is, given an integer array nums, return all the triplets such that I not equal to j, I not equal to k, and j not equal to k. And the sum of these three triplets, the sum of these three numbers should be 0. Notice that the solution set must not contain duplicate triplet. So the problem is saying we have given an integer array, so we have to find triplets in this array such that the sum of those triplets will be equal to 0, but we don't want any duplicate triplets in the solution. So now let's see what the problem is saying. I have copied this array from the problem. So we have given an integer array, and we have to find the pair of three numbers such that the sum of these three numbers will be equal to 0, but we don't want any duplicate triplet, which means if we found one triplet which is -1 1 0, this is the triplet whose sum is 0. So we can't use this again, which means if we find another triplet which is let's say -1 uh, 0 and 1 again. So although this and this have their sum equal to 0, but they are similar, which means 1 minus 1 and 1 1 and 1 0 is there in both the arrays. So we don't include these duplicate triplets in our answer. So now let's discuss the approaches we have to follow to solve this problem. So the first approach is obviously the brute force approach. We will see how we can solve this in most optimal way. But before solving it in most optimal way, let's try to solve it. Just solve it with using any method. So first we will use brute force approach. What brute force approach will do is it will take one number and try to find the combination of three. It is basically it will find every triplet in this array, every triplet which is possible in this array, and then it will calculate their sum. If the sum is equal to 0, then it will store that triplet in our answer, otherwise it will ignore that. So for that we need triplets. So for brute force we will use three for loops, sorry for the handwriting. So three for loops, we will use three for loops, and the first for loops will hold the first value, and the second for loop will hold the second value, and the third for loop will hold the third value. And we have one more condition here, that I should not be equal to j, I should not be equal to k, and j should not be equal to k. So what does that mean? It means if we are taking I as this, so we cannot take j as this, we have to take another number. So for that we will use some condition in our code. Now let's try to code this brute force approach in our Leetcode. So so let's start with the first for loop. So for I in range of, we will iterate over the nums array. So I in range of length of nums. So this is our first loop, and our second loop is for j in range of I plus 1 till the length of nums. Why we are writing I plus 1 here? Because we don't want I and j to overlap. That's why we are writing I plus 1 here, because from this number I will start, and from this number our j will start from the second element. So now let's write another for loop. So for k in range of j plus 1 till the length of nums. So why we are writing j plus 1 here? Because we don't want j to be equal to k. So that's why we are writing j plus 1, I plus 1, and this. So now we have to find if the sum of these three elements, which is nums of I plus nums of j plus nums of k, if the sum of these three elements is equal to 0, then we will store this solution in our So which data structure we can use for for ignoring duplicate values? So in our two-sum problem, we have seen that we use set if we don't want any duplicate value in our answer. So we will use set here, because set, if you will, let me explain you. If you are passing 2 in the set, and 2 is already in the set, then this 2 will be ignored by this set, and it will only hold 1 2 here, because set only store unique values. Set only store unique values. That's why we are using a set here. And why we are storing only unique values? Because we don't want any duplicate triplet in our solution. So we will use set as our answer. Now let's store these answers in our set. So set s dot add. Now we will add, we cannot directly add list in set, because list is not hashable. If you will try to store like this, if you will try to store it like this, nums of I comma nums of j comma nums of k, if you will try to store it like this, it will give you an error of list is not hashable. So we will not use list, so we have to typecast it into any other data structure which is hashable. So tuple is hashable, so that's why we will use tuple here. And we have to sort this. So let me explain why we have to sort it sort this before storing it to set. So if you will see here, let's say, let's take that example again. If one triplet is 1 0 and 1, and the another triplet is 0 minus 1 and 1, so these two triplets are same, but our these two triplets are same, but our set will not recognize it, because the elements are different in both the lists. So if we will sort this, so let's say the sorted array is minus 1 minus 1 0 and 1. So this is the sorted solution. So if we will sort both of this will look like this. So our set will recognize that this solution is already in the set, so we don't have to store this again. So that's why we need to sort this solution. So for sorting, we will directly write sorted. So this will sort this triplet, and this tuple will typecast this list into tuples, and after that it will get stored in our answer, which is set. So now we have to return our triplet solution. So as you can see here, the output is in the form of list, but we have stored our solution in set, so we have to typecast it again into the list. So we will use list, and we will pass our set in this. So this line will typecast this set into list. So the return statement will return a list of triplets. Now let's run this code and see if it is working or not. I think there is some, okay, so this is not num, it is nums. So now let's run the code. So as you can see, we have passed every test case, but if you will try to submit this code, this will give you the time limit exceeded error, because it is using 3 for loops, and the time complexity of this code will be big O of n cube, because we are using 3 for loops. So the time complexity becomes big O of n cube. So we don't want that. So now we have to optimize this solution. And find more optimal solution. So now let's discuss another approach, that how we can solve this. So let me erase all of this. Okay, so now let's discuss the more optimal solution for this brute force approach. So let's read the problem again and understand that what this problem is stating. So we need to find 3 numbers, and the sum of those 3 numbers should be equal to 0. So let's say those 3 numbers are A, B, and C. So those 3 numbers are A, B, and C. So we want the sum of these numbers to be equal to 0. Now we are using three for loops in the brute force approach. We are using 3 for loops in brute force approach. Now let's try to optimize this solution first. We will find the most optimal solution in the end of the video, but let's try to optimize this brute force approach first. So we need 3 numbers, so that's why we are using 3 for loops. Now let's break this solution into parts. So we want the sum of A plus B plus C to be equal to 0. Now with first for loop, we will find the A value. with second for loop we will find the b value, but we don't need third for loop actually, because we have a value and we have b value, and with these two values we can find c. Let's check how we can find c. So if we will see the formula, so it will become a plus b minus a plus b. So this is the formula of finding c, because if you will send these two elements here, uh, that side of equal to, so this will become negative of a plus b. So for finding c we don't need another for loop, so we can use two for loops, and we can directly find the third element without using any loop. So let me code this, and after that I will explain you that what this approach is. So let's erase this, try to write the optimal solution of brute force. So we will start an empty set for storing our answer. So this is the answer set. After that we will start a for loop for I in range of length of nums. So this will be our first for loop. So by this we will find the first element of the triplet. Now we will store this in a. So we have found a, which is nums of I. Now we will use another set. I'll first let me write the code, then I will explain it to you why we are using this set again. So then we will find our next element, which is j. For j in range of I plus 1, because we don't want to overlap I in j. So I in range of j in range of I plus 1 length of nums. Then we will calculate our now we have a and we have b, which is j. So now let's name it. Okay, so we have a, we have b, we have to find c. So the formula to find c is this. Now let's code this. So c will be equal to minus of a plus b, and what is b? B is nums of j. So now we found uh, c here without using any third for loop. So if c is in if c in s, if c is already in the set, then we will we know that we found our triplet. So we will again store this triplet in our answer. So a answer dot add tuple sorted, and here we will pass our solution list nums of I, nums of I, nums of j, and c. We have found our first triplet, which is nums of I, nums of j, a, b, and c element. And after that we will store or add this element s dot add nums of j in the solution, because because we want we will add this nums of j, so we can find this again in the solution. So nums dot add s dot add nums of j, and after that we will break the for loop and return our solution in the form of list. So list of answers. So now let's run this code and see if it is working or not. Okay, again I wrote num instead of nums. So yeah, we have passed again, we have passed all the test cases. Our answer is right. Now if you will again try to submit this code, you will get an time limit exceeded error, because we have optimized the brute force approach, but this is not the most optimal solution. The time complexity of this approach will be, because we have used two for loops, so the time complexity of this will be big O of n square. But what if I tell you that we can do this solution with the time complexity of big O of n? Now let's see how we can do it. So before that, let me explain you that how this code is working. So we have initialized an empty set, and after that we have started our first loop to find the first element of the triplet, and we have stored that first element in nums of I in a. So we have found our first element, and then we have initialized empty set again to store this j element, so we do not have to find this j element again and again using for loop. So we will store our element in this, and we will calculate c. Before for finding c we will not use another for loop, we will directly find this c using the formula which we have calculated here. So we will find c directly with using a and b element, which is a and nums of j. So this is the formula of finding c, and then we will check if c is already in the set or not. If c is already in the set, which it means we have found our triplet. And why we are writing this code, because we don't want any duplicate triplets, so that's why we are sorting these numbers, and we are typecasting into tuple because set cannot store list directly. And after that we will add this element nums of j in this set, because we if we will not add this element, this set will be empty forever, and we will not find the triplets. After that we will return our answer in the form of list by typecasting this set into list. So this was the optimal solution of brute force approach. Now let's move towards the most optimal solution of this problem. So let me discuss the most optimal solution for finding the threesome problem. So for that, you should know that how to solve this problem, which is twosome 2. So I will again recommend you watch these two videos on my channel. I've already uploaded these two videos. So because this threesome problem is very similar to these twosome and twosome 2 problem. So now let's discuss the optimal approach for solving threesome problem. So now just think, if this array was sorted, if this array is sorted, let's sort this array. So the first element will be -4, and the second element will be -1, then again -1, -1, and 0 and 1 and 2. So this is the sorted array. This is the sorted array. Now if first we will find the first element, which is I of triplet. First element is I. So let's say our first element is this. So this is the first element. Now we have to find two numbers of triplets, which is uh, j and k, j and k, such that the sum of these three will be equal to 0. So now this array is sorted, and if you remember in this question 2 sum 2, the array is sorted, and the problem statement of this question was we have to find two numbers such that the sum of those two numbers is equal to the target value we are searching for. So this is the same case. We have sorted array, we have sorted array, and we have one number, first number, which is -4, and we have to find two more numbers such that the sum will be equal to target, and our target is 0. So let me write here, the sum should be 0. So what we are finding here, we are finding two numbers such that the sum of these two numbers with I will be equal to 0, and the condition is the array is sorted. So what we did in this solution, in the solution of 2 sum 2, we have started two pointers, left and right. Now in 2 sum problem we have started the left pointer from the first element and the right pointer from the last element. But in this threesome problem we don't want any overlapping between I and j. So we will start our j pointer, which is a left pointer, from I plus 1, which is this element. So we will start our left pointer from this element I plus 1, and our k pointer from the last element. So this is our k pointer. Let me erase this. So we'll start our right pointer from the last element, which is k, and now we have a element, b element, and c element, and we have to find if the sum is equal to 0 or not. So we will check I plus j plus k is equal to 0 or not, is equal to 0 or not. So if the sum is equal to 0, then we have found our triplet, and we will store this in a list. But if the sum is greater than 0, which means or smaller than 0, it can be greater than 0 or smaller than 0, because we will not get 0 always as a sum of these three numbers. So let's try with the first element. So let me write it here. So our first element is this, which is -4, and our j is pointing to this element, which is -1, and our k is pointing to this element, which is 2. So the sum of these three numbers will be -5 plus 2 equal to -3. So the sum of these three numbers is equal to -3. So this is smaller than 0. The sum is smaller than 0. In this case, the sum is smaller than 0 because the sum is -3. So in this condition, what we will do is we will move this j to the next position. We will move j one step further. Now the value of j is, so there is one more problem in the sorted array, is that we have neighboring element equal, which means if there are duplicate numbers, we have them in neighboring elements. So we have to deal with that problem also. Now let's first discuss the problem like this. After that we will handle special cases. So now let's say our j is here now. So j is pointing to 0, and k is still pointing to k, and I is still -4. So now our I is -4, our j is 0, so +0, and our k is pointing to 2. So this is 2. Now the sum of this will be minus 2. So this is again still it is smaller than 0. So we will again move this j pointer here. Now our j is pointing to 1. So we will again calculate, and we will calculate till we find the sum equal to 0. And when we will find the sum equal to 0, we will store this answer in our list. Now let's code this and see how it will work, and then we will discuss the special cases and what are the anomalies in this problem. So let me copy it here and let's start coding this. If you're not understanding this now, after I will write the code, I will dry run it, and then you will understand it clearly. So now let's write the code and understand that how this solution will work actually. So the first thing we have to do is sort the array. So we will sort the nums array. We will write nums.sort. Now our array is sorted. Then we will again start an empty set. Although we don't need a set anymore because our solution is already sorted, but we will use set. So now the first thing we have to do is we will start with start our I with this element, and we will start two more pointers j and k. Sorry, we have this sorted array. So we will start our I from this element and our j from one I plus 1 and our k to the last element. So let's start initialize I. So for I in range of um, length of k, length of nums minus 1. Why we are writing this minus 1 here? Because we don't want I to be equal to k, which means if we will not write this here, the last element and the ith element will point to the same element, and we don't want that here. So we will write minus 1, and then we will start our j and k pointer, which is our left and right pointer, because array sorted. So j pointer will point to the first element, which is I plus 1, and k will point to the last element of the array, which is nums, which is length of nums minus 1. So this is pointing to the last element of the array, and this is pointing to the second element from I plus 1, second element of the array. Now the condition is we have to iterate over this array until j is smaller, till j is smaller than k, which means if j is equal to k, we don't want j to be equal to k here. So we will stop our loop here where j is smaller than k. If j is equal to or greater than k, this loop will end. So we will start another loop. So while j is less than k, we have to start this loop, and then what we will do is then we will calculate our sum. So the sum will be nums of I plus nums of j plus nums of k. And if, and we have to write if condition, if the sum is smaller than 0. If the sum is smaller than 0, then what we have to do is, if the sum is smaller than 0, then we will shift our k pointer to the right side. So we will shift our j pointer. Then we will shift our this j pointer. Let me choose another ring. Then we will shift our this j pointer to the right of the array. So we will write j plus equal to 1. And if the sum is greater than 0, then we will shift. If the sum is greater than 0, then we will shift our k pointer to the left side, which is minus equal to 1. If the sum is greater than 0, then we will shift our this k pointer to the left side of the array. And else, the last case is if the sum is equal to 0, then what we will do is, then we found our triplet. So we will store this triplet in our answer. So s dot add tuple nums of I, comma nums of j, comma nums of k, and we will increase the j and k pointer also. So now this is the solution, but in this solution we have two problems that we have to address. So let's see what are those problems. Let me copy this array and paste it here. So let me copy this array and move it here. So we have this sorted array. Now what we have to do is let's say our I is pointing to this element, and let's discuss the second iteration. Let's say our I is pointing to this position, and after that our I will, in second iteration, our I will come here. But this and these two elements are same. This is minus 1 and this is minus 1. In that case, our I is pointing two times on the same element, because this array is sorted. So we have every similar element in the neighboring point. So in this case, I is pointing to the same element. We have to deal with this case first. So to deal with this case, we will write here, before increasing or decreasing the I, we will write here if I is greater than 0. If I is greater than 0, it means if I is on the second or third element, if I is greater than 0, and nums of I, which is the first element, is equal to the previous element of the array. If these two elements are equal, in that case we don't have to do all this solution. In that case we don't have to do all this, so we will simply continue from there. So in that case we will continue and we will not calculate all this in that case. And the next case is, let's say um, in next case let's say our j is here, and in second iteration our j will move here. So our j will move here. So here first we have calculated it for -1, then we have to calculate it for -1, because in sorted array neighboring elements are equal, may be equal. So we don't want to calculate our sum for similar value of j, so we have to deal with this solution, this problem also. So for this we will easily write here that and in sorted array it can be like this: the first element is 1, the second element is also 1, the third element is also 1, fourth is also 1, and then we have fourth is also 1, and then we have 2 and so on. Then we have 2 and so on. So in first case, let's say our j is pointing here, then j is pointing here, and then j is pointing here. So these three elements are equal. We don't want, if we have calculated our sum for j equal to 1, we don't want to calculate it again for j equal to 1 and j equal to 1, no matter on which index j it is present. So in that case we will skip these two elements and we will move towards this unique element. So for that we will write while j is less than k and j is less than k, until j will reach the last element which is less than k. Here we want to check if the current element, which is nums of j, is equal to nums of previous element. And if it sorry, if we have to check this. Okay, so if until the j is less than k and the current element of j is the current value of j is equal to the previous value of j, then we have to skip j, which means we will plus equal to 1. We will increase the j until the value of j will be unique, which means this condition is false. Then we will iterate through this loop again. Until that we will iterate in this loop and we will increase the value of j until we will find the unique value, like 0 or 1 or 2, until we will run this loop. Now we after this we have found our unique solution, unique triplets. So we will directly return this here. So we will return the list of our solution, which is s. So now let's run this code and see if this code is working or not. After that we will dry run this code and check the solution. So it is saying that int has no attribute to add. Okay, so we have initialized to a variable with same name, so let's call it answer, and we will add answer here, and we will return answer here. So we have initialized this variable and this variable with same name. That's why it has confused. So yeah, we have passed all the test cases, and now let's submit the code and see if it is working or not. So this time this will not show the time limit exceeded error, because this is the most optimal solution of the problem. So as you can see, we have passed every test case. Now let's discuss that what we can change in this. So instead of set we can use list here. Let me show you. We can directly use list here, l equal to, we will initialize empty list. And because we are dealing with duplicate element here, duplicate I here, and we are dealing with duplicate j here, so we don't need to store the unique solution, because we are making the solution unique by this and this. So we can directly append this solution in our uh, list. We don't need to typecast this. We can directly store this in list, and we can directly uh, return the list. And if you run this code, this will not show you any error, because yeah, so every test case is running, because we don't need to store unique solution, because we are already handling every duplicate value of I here and every duplicate value of j here. So this is the solution, guys. And if you have not understand it yet, you please try to dry run this code, and after that you will see that how this code is working and how it is the optimal solution of the code. So the time complexity of this code is big O of n log n, because we are sorting the array here. So this will give you log n time complexity, and this is the most optimal solution for the threesome problem. So that's it for the video, guys, and thanks for watching.